Hello, so today's video is just to cover off how simple it is to create a route-based VPN tunnel between two FortiGates. So this is the topology I have. Now, this topology is actually going to be used to build a far more complex environment. But the reason I want to focus purely on the simplicity of doing a route-based VPN came out of a conversation I had with somebody on LinkedIn. So for the purposes of this, I'm just going to create a route-based VPN tunnel between branch 1 and hub 1 here. And then what we're going to do is we're going to enable OSPF, and we are going to then inject the routes from these loopbacks between hub 1 and branch 1 over that route-based VPN tunnel. And we'll see that we will be able to ping those two natively without any need for GRE within the IPsec tunnel. FortiGate's IPsec natively supports multicast, so obviously OSPF relies on 225.0.0.5 and 0.0.6. So as I said, we don't have any need to run additional protocols simply to facilitate multicast. So let's start off with here. I've got hub 1, and the first thing we're going to do is we're going to create those loopback interfaces. So we'll just call it loop 1 here, and the type is a loopback, and we're going to go 10.1.1.1/32, and we'll enable ping and get rid of the object. Okay, we'll go across to branch 1 and we'll do exactly the same thing, and call it the same thing. Loopback 10.2.1.1/32, get rid of that and enable ping. Right, so we can see here that my IP address on the hub is 2.10 and on the branch is 2.1/30. So as per the diagram here, I've got a router in between the two that is facilitating that, and I've got the static routes pointing to the fact that so that these FortiGates know that they must reach out to that router in order to get to these things. In fact, I don't need the 10 one because we're going to be doing that over the IPsec. So let's just get rid of that quickly. Delete. Okay, because we want to push that over the IPsec tunnel. Okay, now obviously that is so I can get to these virtual machines on my ESXi server and manage them. Right, so now what I can do here is on the hub, I can either create a point-to-point tunnel using the IP addresses, or I can use a dial-up. So if I have, as in this case, I've got maybe, it could be hundreds of branch sites, I don't particularly want to be setting up individual IPsec tunnels for each one of those. So in that case, I would have the hub as a dial-up. Now that doesn't mean we are forced to use aggressive mode or we can't use IPv2 or any of that. No, that's not the case at all. It's just a way of conveniently setting up the connections. So let's start with that. So let's go create IPsec tunnel, and we'll call this hub dial-up. Helps if I spell correctly. Here we go, custom. And now I'm going to say this is a dial-up user, and I'm going to use the interface, the outgoing interface that is reaching to that router, port 2. And here I can use certificates, or I can use pre-shared keys, I can use IPv2, or I can use IPv1. I'm just going to stick with IPv1 for now, and we will give it a pre-shared key. And here is where I could choose. Let's assume we had many different customers terminating on this, or many different business units, and we wanted to differentiate them and have different dial-up tunnels for different customers or different business units. Here I could use specific peer IDs to differentiate them, but in this case I'm going to say accept any peer ID. The rest I'm just going to leave default. Obviously here you can change things as you so desire for whatever encryption standards you want. This is the phase 1, and these are all pre-configured for you on a FortiGate. All right. The only thing I would say is that this is 748 FortiOS, and here the phase 2 is pre-configured. Later versions, 7.6, you have to do this, but all the same capabilities exist. And we're going to say auto keep alive just to keep those tunnels up and running, but everything else I'm going to keep quite simple there. Okay, so that's up and running. And let us just double check this. So I've got to go to 210, and we can see on port 2 that that IPsec tunnel is now bound to this interface, and this will be the internet facing interface in this instance. Okay, now the other thing we need is a policy. So just to make my life simple for now, I'm going to come along here and I'm going to say allow multiple interface policies, and I'll explain why I'm doing this in a second. And I'm going to say allow unnamed policies and apply that. And I'm doing this purely for the simplicity of this this video. Okay, but let me just wait for that to come up. Now, ordinarily when you create a IPsec policy, because an IPsec tunnel is formed of two security associations, you would have one policy outbound and another policy for the return traffic. Okay, we don't need that for policy-based VPNs, but it would be the case for route-based VPNs. Now, what I'm going to do here is I'm just purely, again, I'm not suggesting this is the way you do it in the real world. This is just for the simplicity of this. I'm just going to call this any, so basically accept anything. And I'm going to say coming from any interface, going to any interface, from any source, going to any source. Okay. In fact, no, let's constrain that down a bit. Let's constrain that down. Let's be diligent. Let's go from loop 1 to the IPsec tunnel, and then we'll do the reverse here. IPsec tunnel back to loop 1. So here, by doing this, I don't have to create the reflexive policies. That's done inherently within here. Okay, and then I'm going to say let's allow all services, and close that, and I'm going to switch off NAT because I don't want NAT running, because we're going to be running a routing protocol. And I click OK. Now here's the thing, unless you've got a policy, you let's just go here and go by sequence. All right, now you'll see there that I've done this, but in the background the FortiGate actually created the reflexive policies. Okay, now if I just go back here again, you can see it's much simpler to view it in this format here. And here I want all logging on, not just unified threat mitigation. Okay, so that's up and running. Now, unless there's a policy here, the tunnel won't come up. So this is one of the provisos of getting the IPsec tunnel up. Now, what I'm going to do on this side, I'm going to do the reflexive. I'm going to come along here, IPsec tunnels. I'm going to say create an IPsec tunnel. I'm going to call it to hub. And I'm going to go custom here as well. I could use these little cheat things, but I prefer to do it manually. This way you can see what's happening. And here I go 172.168.16.2.10, and I'll go my outgoing interface is port 2, and here I'm going to use the same pre-shared key. Everything else can stay the same. Remember that even though this is a dial-up, if I come back here for a second, I'm still in main mode here. I haven't had to go to aggressive mode. Alright, so come along here. We're not using any peer ID, so I don't need that. The phase 2, as I mentioned earlier, is already set up. And I'm going to go auto negotiate. So as soon as the device finds that it can do it has a route to the destination, it's going to bring up that tunnel. Now, I'm going to do the same as I did here on the other one. I'm going to allow that, and I'm going to have multiple interface policies, and I'm going to go policies, firewall policy, cancel, I don't want to use that. Okay, create new, I'm going to call this VPN to hub, incoming interface, and I'm going to put both of those again, loop and the IPsec tunnel. Outgoing is IPsec tunnel and the loop back. source, anything between those two interfaces. And all services, switch off NAT. Okay. Right, and again, if I come back to the sequence, we can see that the sequences are there. And then I can see that that tunnel has now gone green, which means that that tunnel is up and running. Okay, job done. Tunnel's working. Now, because this is a route-based, I've got two choices. I can use IP unnumbered on those tunnels, so I don't need to actually specifically number the tunnels. But in this case, I'm going to. So I'm going to come along here, and I'm going to go tunnel, and let's call it 192.168.10.2. The remote is 192.168.10.1/24. Ping, in fact, let's just make that /30 because we just got a point-to-point here for the moment. We come along here. Now these, once you set up the tunnel basically acts as a pseudo wire, right? Remember, this is just like if you've got a leased line. So irrespective of the fact that it's an IPsec tunnel, it's operating just like a point-to-point circuit. .10.2/30 ping. Right, so I should be able to ping. Hold on, I need to enable pings first. Let's just go back. I did that. Did I just check that I did that? Ping on that side. Ping on that side. Yes. So let's go execute ping 192.168.10.2, and there we go. So now I'm pinging across those tunnels, right? Life is good. But I still can't ping. So if I do an execute ping 10.2.1.1, I can't ping that because the hub has no idea how to get to that. So let's go and switch on OSPF. So there's my router ID. Let's use that as 10.1.1.1, which is the loopback of this device. We'll set up area 0 simply, and here I'm going to say area 0 10.1.1.1/32, and then I'm going to put in the interfaces that are participating in that. So I'm going to go IPsec. And that name can be anything, right? It's just a placeholder. You know, we choose the actual IPsec tunnel. He has all the various things that you can do with IPsec if you so desire with OSPF, and a lot more within the CLI. So when I do that, what it's doing is it's obviously creating the OSPF constructs in the background. So if I do a show router OSPF, all right, I haven't clicked apply yet, but once I click apply, there we go. All right. So now that OSPF is running, if I come along to the branch here, OSPF, again, here I'm going to do 10.2.1.1, and I'm going to create my area. And I'm going to put in the networks that I want to publish, which is 10.2.1.1/32, and the interface that I want to participate, and IPsec, and go there, click OK. Summary addresses, don't need that. Click apply, and once more, if I do a show router OSPF, we can see that. You may have noticed that when I did that, there was also an OSPF 6 option. So we support OSPF for IPv4 and IPv6. Right. So if I did apply, okay. Now if I do a get router info OSPF neighbor, it may take a second or two. So let's do got that. Okay, we're just waiting for it to negotiate. networks, IPsec. Oh, sorry, I need to put in the network for the actual IPsec tunnel as well. What did I make it again? 10. 192.168.10.0/30. Apply networks 192.168.10.0/30. Okay, apply. Router info, OSPF neighbor. Okay, and now we're up and running. So do the same on this side, and we're up and running there as well. So execute ping. So let's first do get router info routing table all, and we can see that we have learned that 10.1.1.1/32 from the branch side. And if I come on this side, get router info routing table all, and I've got that from that side as well. So if I do an execute ping 10.2.1.1, there we go. So I'm pinging. I've created my route-based VPN. I've enabled OSPF, and I'm pinging. Plain and simple. No extra protocols required, no GRE required. It simply just works. Now, obviously, that's a very simple setup. What I will do is on the back of this topology, when I've completed this, which is going to be far more complex, it's going to include virtual domains, multi-tenancy, multi-termination points, then I will create another video and go into more detail with that. There are also things that you can enhance in terms of your visibility here. We can come along to this dashboard and I can look at IPsec statistics here. So if I add in IPsec, click OK, I can see my IPsec monitor. I can now see the traffic that's flowing. I can do exactly the same on this side. Dashboard, IPsec. Add that there as well, and again I can see that both sides. So if we were using PIIDs, you would see the PRID here. You can see the traffic that's flowing. You can see your state of your phase 1 and your phase 2 selectors. So hopefully that was useful to any techies out there. As I've always said with my videos, these videos are not intended to be crisp, clean-cut, polished marketing videos. These are technical videos done by a techie for other techies. Thank you very much all. Bye-bye.